Good evening. Today we'll be continuing with Chapter 6 and we'll be looking at lessons 7 through 9.
Lesson 7 begins with graphing a line, and there are certain key ideas that the book focuses on. The linear equation has two variables, x and y, and when the solutions to a linear equation are graphed on a coordinate grid, the graph forms a line. So to find a point rather on the line, you want to substitute a value for x and solve for y. And you must solve for at least 2 points in order to draw the line. Using the coordinate system, we can graph equations. When an equation has only two variables, say x and y, for example, and neither is raised to an exponent, the graph of the equation will be a straight line. And we'll see many examples of that today. When the graph of an equation is a straight line, the equation is a linear equation. To graph an equation, you need to solve for 2 points on the line. So here's our first example. We're being asked to graph the equation y equals 3x minus 4. So the first thing you want to do is just choose any value that you like for x and then solve for y, right? Remember how we discussed in our earlier lessons that, let's say we decided that x was 5. Everywhere in our equation where we see x, we will just substitute x for 5. So in this particular example, they've chosen x equals 1. So we're going to go back to our original equation and we're going to substitute 1 into x. So 3 times 1 is 3, minus 4 is negative 1. And so we have our value for y. And this just simply means that whenever x is 1, y will be negative 1, okay? And so that's our first ordered pair, right? We have 1, negative 1. 1 for, remember we always write down x first. So here's our x, which is arbitrarily decided that it was 1. And here's the value negative 1 that we found for y when we plugged in x, okay? And then we'll do the same thing. We'll choose another arbitrary point. They've chosen 2 this time. So we're going to go back to our original equation, plug in 2. 3 times 2 is 6. 6 minus 4 is 2. And so now we have our second ordered pair, 2, which is the arbitrary point we chose for x, comma 2, which is what we found for y. So this just simply means that whenever x is 2, y is also going to be 2, or the value for y is also going to be 2. And so we can then go on our coordinate grid and we can plot our ordered pair. Start with the first one. We decided that it was 1, negative 1. So we'll start at the origin and we'll move 1 space over to the right to represent our value for x, right? So here's 1 on the x-axis. And then we're going to move 1 vertical space downwards to represent the value that we found for y, which is negative 1, right? So here's the location of our first ordered pair. And then our second ordered pair was 2, 2. X was 2 and y was also 2. So we're going to move 2 spaces, 1, 2 on the x-axis, 2 spaces to the right, because 2 is positive. And then we're going to move 2 spaces upwards on the y-axis because y is also positive. And so here's our location for 2, 2. And then you can grab yourself a ruler and just draw a straight line connecting both of your ordered pairs, or both of your points, your coordinate points that you've indicated based on your ordered pairs. And now you have the line for the equation y equals 3x minus 4. Okay. This line is the graph of all the possible solutions for the equation y equals 3x minus 4. The arrows on the ends of the line indicate that the line continues in both directions into infinity. From this, you can see that there is an infinite number of solutions to a linear equation, right? As long as we pick any point on this line going on into infinity, those 2 points will be the solution for this equation, okay? Some linear equation problems don't require you to draw a graph. It's just a random note. But now we know how to graph a line when we are given a certain equation. All we have to do is just start by picking any point or any value that we want to represent x. And we'll know that whenever x is that value that we've chosen or the value that we specified, we can always find the corresponding value for y, right, to give us our ordered pair on any point, and that ordered pair will represent a point on this line. So here's a GED test tip. If a linear equation is not written with y on one side of the equation, you want to use inverse operations to isolate y. So for example, 2x plus y equals 15. In order to make this clearly represent the slope of a line so that we can find ordered pairs and plot the line, you would need to isolate y, right? And in this particular instance, to isolate y, we can simply just subtract negative 2x from both sides. So negative 2x, if we subtract negative 2x from the left-hand side, we'll be left with y. And if we subtract negative 2x from the right-hand side, we'll have negative 2x plus 15. Okay, or you can simply just think of it as taking this 2x, moving it over the equal sign, and we know that from our previous lesson, we know that anytime we move a value over or a term over the equal sign, it changes sign, right? So if we move 2x over the equal sign, we'll have negative 2x on the right-hand side, okay? Point A lies on 5, negative 6. Okay, so this is the coordinate pair on a grid, the graph of which of the following equations passes through point A. It's asking us which of these lines is the correct line for this particular set of points. Meaning, if we decided that we were going to plot these 3 lines, which one of them would accurately reflect this ordered pair? So you can simply just use the ordered pair that you've been given and substitute the relevant values or the relevant variables into the equations. So if we look at option 1 and we let x equals 5,
negative 5 times 5 is negative 25, and negative 25 plus 18 is negative 7.
So 1 can't be the right answer because this ordered pair is letting us know that anytime x is 5, remember we always write x first, right? So think of this as our xy pairing that we learned about last class. So in this particular instance, x equals 5, y equals
negative
6. So this ordered pair is letting us know that on our coordinate plane, if we move 5 paces to the right on the x-axis, we have to move 6 paces downwards on the y-axis. So when we plug in 5 into one of these equations, y should equal negative 6. And we've already tried the first equation.
And we found that when x equals 5, y is equal to negative 7.
So we're going to move on to the next equation. We're going to plug in 5 into x. Negative 4 times 5 is 14 is negative 6. So we have found the correct answer, but let's just try with the third equation. So 5 times negative 2 is negative 10. Negative 10 minus negative 13 is negative 23. So this doesn't work. We already know that the second option is the correct equation, but I just wanted to, emphasize the point by plugging in the ordered pairs into this third equation so that you can see that there's really only one solution
in the set of options that we've been given that applies to our ordered pair.
So essentially, option 2 is the correct solution. We plugged in 5 into x. Negative 4 times 5 is 14 is negative 6. And so we know that option 2 is the correct solution for this particular set of points. Do you have any questions?
No, it makes sense. I'm following.
Okay. So we'll practice exercises starting on page 975 to 978. Lesson 8 is on the slope of a line. And so the key ideas to keep in mind is that a slope is essentially a ratio of rise over run. So all that we've been doing here, moving one pace over to the right, for example, and then one pace downward.
I should mention really quickly that this is the slope of the function at the point that we've identified as our ordered pair. Okay, so this is the point slope of our line, or the slope of our function at the point 1, -1, which represents the slope of the tangent line to the curve at that specific point, or the instantaneous rate of change at that point. In other words, the instantaneous rate of change at the point 1, -1. Okay, and this is not the slope of the entire line itself, which altogether we've covered this in a previous lecture a few weeks ago, but we'll revisit this. Just know for now that we're dealing with the instantaneous rate of change, or the slope at the point 1, -1. Okay. And the great thing about that is that the slope of a straight line always remains constant. So whether you're dealing with the instantaneous rate of change, which in this case would be the slope at point 1, -1, for example, or whether you're dealing with the average rate of change, which would be the slope of the entire line, just know that the slope will always be constant, or will always stay the same at any point along this line. So if we wanted to find the slope for this particular point, 1, -1 on our line, since we only have one ordered pair at the point 1, -1, we can just choose any other ordered pair as long as our choice is located on the line that we're working with. So let's, for the sake of convenience, use the second ordered pair showing here, which is 2, 2. Then using our slope formula, which we learned about a few weeks ago, in the numerator of our slope formula, y2 minus y1 would equal 2 minus a -1. And in the denominator of our slope formula, x2 minus x1 would equal 2 minus 1. So back to our numerator, 2 minus -1 is positive 3. And in the denominator, 2 minus 1 is 1. 3 divided by 1 is 3. So our slope at the point 1, -1 is positive 3. And I emphasize positive because you can use the sign of your slope to gauge whether or not you found the right slope, at least in terms of directionality. So we've previously discussed that the slant of a line is a good indication of its direction, and the sign of its slope, sign being positive or negative. So here we see that our line slants upwards and to the right, which is indicative that the slope is positive, and we found positive 3 as our slope. So our positive slope matches the behavior of the line, or the fact that our line slants upwards and to the right, indicating that we have a positive slope, right? And since we know that the slope along a straight line always remains constant, the slope at point 2, 2 would also be a positive 3.
So moving from left to right on a line that goes upwards has a positive slope, and a line that moves downwards has a negative slope. You can find slope by counting spaces and writing a ratio, or by using the slope formula. So slope is the measurement of the steepness of a line. Imagine a road going up a hill. If the road must climb upwards over a short forward distance, the road will be very steep. Slope measures the relationship between rise, how high the road must climb, and run, the distance the road goes forward. So on a coordinate grid, a line that moves from left to right has a positive slope. So this, in this particular instance, this is our left-hand side, and this line is moving from left to right. Okay, so this particular line has a positive slope, and a line that moves downwards, from left to right has a negative slope. So let's say we started at this point here, and we move downwards towards the right, and we drew a line from this point to maybe somewhere in the space, and we connected the 2 points, that line would have a negative slope because it's moving downwards from left to right. You can find the slope of a line on a coordinate grid by writing the ratio of rise to run. So in this example, we're being asked, what is the slope of line P shown on the coordinate grid? So this is line P, and the equation of line P would take on the form that we saw earlier. The standard form for any line is y equals mx plus b. So it will always look something like this, where m is the slope. So in this particular instance, the slope is 3. This is our x, and then the standard equation always appears as plus. This is the value for b. In this particular instance, b, or the y-intercept, is -4. And the y-intercept is the point that this line crosses the y-axis. So if we were to continue to draw this line, at some point it's going to cross that y-axis. In this particular instance, they're telling us that this line crosses this y-axis at -4. So here, when we're being asked to find the slope of line P, shown on the coordinate grid, all we have to do is find 2 points on the line, and then we're going to count the rise and the run. The line moves upwards 1 space, okay? For every 2 spaces, it goes to the right. So for instance, if we started at this point, we would have to move 2 spaces to the right, 1, 2, and then exactly 1 space up to find the next point on the line, or to stand on the next point of the line. And we can try that for any other point on the line. Let's say we started here, right? We would have to move 1 space up and 2 spaces to the right, 1, 2, and here we're at the next point on the line. So that's essentially what the slope of the line represents, the ratio of the number of steps that you have to move either to the right or the left, and then either upwards or downwards to connect 2 points on the line.
In its true essence, the slope of a line really refers to its steepness or the direction of the line in the context of a coordinate plane. It's a numerical value that indicates how much the line rises or falls vertically for every unit that it moves horizontally.
So in this particular instance, we would just write our slope as our rise. Again, we moved 1 point upwards. Over our run, we moved 2 spaces to the right. And so the slope, or the ratio, is 1/2. So think of the slope formula in this way. Write the difference of the y's over the difference of the x's, and then just make sure that you always subtract the coordinates in the same order. So in this example, we're being asked to find the slope of line S shown on the coordinate grid. So here's our line, and they've named it S, and we're being asked to find the slope of the line. So what you want to do is start by finding any 2 points on the line. So here they've arbitrarily or randomly selected 2 points on this line. And then we're going to find out how we can, if we step out of the line, how can we get back, or how can we get to another point on the line without stepping on the line itself? So if we start here at this randomly chosen point, we would have to step 2 paces over to the left, okay? So we're starting here, 1, 2, and then we would have to move 6 paces upwards, 1, 2, 3, 4, 5, 6, to get to the next point on the line. So in this particular instance, our slope, or our ratio of rise over run, is -2, the number of paces that we move to the left. Okay, that's our run. And then 6, the number of paces that we moved upwards. All right.
But based on how the book presented the ratio here, it looks like they started with the y-axis. So 6 places down equates to -6 on the y, and then 2 places to the right equates to +2 on the x-axis. -6 divided by 2 is -3.
And so our ratio is indeed -3. Okay, just keep that in mind. Pay attention to what direction you're moving. So if we had moved 2 paces over to the right, we would have +2. But then if we move upwards, we can't connect to this line right here, right? If we move downwards, at some point, -6 paces downwards, we would probably connect to this line because the line continues into infinity, right? And the slope at any point on the line is always the same. So again, the slope of this line is -3, and we got that simply by dividing the rise by the run. All right, so you can find a slope by using the slope formula on the GED formula sheet. The formula will appear as follows. The slope of a line, M, equals y2 minus y1 over x2 minus x1, where x1, y1 and x2, y2 are 2 points on the line. So for example, you can consider this your x1, y1, and you can consider this point your x2, y2. This is just telling you that this is standard notation for finding the slope of a line using 2 points on a line. So in this example, we're told that a line passes through points at coordinates 1, 4, and -5, 2. What is the slope of the line? So you want to choose one point to be your x1, y1, and it doesn't matter. You can, if you want, you can start with this point, or you can choose -5, 2. In this example, they chose, or they let 1, 4 be x1 and y1. So logically, -5, 2 will represent x2 and y2. And all you do is substitute the values into the slope formula and then solve to find the slope. So remember again, the slope of a line is y2. You always want to start with the second y value first, okay? Minus y1 over x2 minus x1. So here we decided that y2 is 2, right? Because we chose this to be our second pairs, and we let this be our first set. So y2 is going to be 2, right? So we're going to plug in 2 in this space where we have y2. Then we got to look for y1. Well, we decided that this first set is our first ordered pair. So that means 4 is y1, right? So we're going to plug in 4 into this position where we have y1. And then we'll just simply do the same thing for x. x2 we decided is -5. So we're going to plug in -5 here where x2 belongs. And then x1 we've decided is 1. So we're going to plug in 1 here where x1 belongs. Okay, and then we just simply follow through with procedural subtraction. 2 minus 4 is -2. -5 minus 1 is -6. And we know from our lesson on signs that when you either multiply or divide two numbers that are negative, the outcome will be positive, right? So in this case, we're dividing -2 by -6. The outcome is 1/3. So the slope is 1/3. Since the slope is positive, you know that the line rises from left to right. You also know that it goes up 1 space for every 3 spaces it moves to the right. In working with the slope, there are several circumstances that you should memorize. A horizontal line, just like a flat stretch of a roadway, has a slope of 0. The slope of a vertical line is undefined. In other words, our definition of a slope will not work for a line that has no run at all, right? So the slope of a horizontal line is 0 because, again, if we think back to our formula for a slope, which is rise over run, or y over x, if we're only moving on the horizontal line, then it means that we have no value for y, right? So at any point on the horizontal line, we can pick any arbitrary number. Let's say we pick 5. So 5 is our value for x. But since we're on the horizontal line, that means that we have no value for y. So if we wanted to find the slope of that line, of that horizontal line, we would be dividing the rise over the run. So since we're not moving on the vertical line, our rise would be 0, and then our run is that arbitrary number that we've chosen in this particular example, 5. 0 divided by 5 is 0. But if we were looking at a vertical line, it means that we can choose any arbitrary number on the vertical line or any random number on the vertical line. So let's say we chose 1. Since we're on the vertical line, we're not moving in the x direction at all. So x is going to be 0. 1 divided by 0 is undefined because you can't divide a number by 0. So that's what this is telling you here, that the horizontal line, anytime you see a horizontal line, it has no slope. And that makes sense, right? Because earlier in our discussion, we saw that car moving upwards, and we were told that slope is rise over run. The amount of paces that you have to rise, and then the amount of paces that you have to run. But if your line is flat, then you're not rising, you're just on a run. Okay, so your slope is 0, which makes sense. For a vertical line, your slope is undefined because, well, you had to rise somehow for that line to be vertical.
But there's no slope. It would be akin to climbing a wall, for example.
And so essentially, the slope of a vertical line is undefined. And if it helps, we can look at our car example again, right? So if you had just a vertical line, it means you have no run. So you would be finding, let's say this point here was 5, you don't have a point for x, right? X would be 0, and 5 divided by 0 is undefined. Or essentially, that's just telling us that we don't have a slope for this line, okay? And the same thing applies to a horizontal line. Well, I shouldn't say the same thing, because the slope of a horizontal line is 0. The slope of a vertical line is undefined. So let's say we picked another random point. On this line, let's say that point was 3. Well, we don't have a y value, so 0 divided by 3 is 0. But this line, we can find a slope because we would have a run and we would have a rise, and we can use our slope formula to plug in those points and find the slope of the line. Okay, and that's all this is telling you right here. So lesson 9 is on slopes and equations. The key ideas that we should pay attention to. There are 2 ways to find an equation if you're given the slope of a line and a point. One method is the slope-intercept form. The other method is the point-slope form. So using the slope-intercept form to find an equation, lesson 8 showed how to find the slope of a line and graph it. The examples in this lesson will show how you can use the slope and a point on a line to find the equation of a line in 2 different forms. So you might also need to find the equation of a line from 2 points. In this case, you would calculate the slope first, and then you would use the slope and one of the points on the line to find the equation. And this will make more sense when we look at examples to follow. So as I was saying earlier, this is the slope-intercept form of a line. In this particular instance, we've now established that the slope-intercept form takes on this general form, y equals mx plus b. So anytime you see an equation that looks something like this, we know that we're being given the equation of a straight line, okay? So that would apply to this set of equations right here. Each one of these equations meets the criteria for a standard equation of a line. So starting with this one, for example, here we have our m, which is the slope, -5, and we have our b, which is the y-intercept, okay? And then we have y representing a point on the y-axis. And then we have x, which also represents a point that we can connect to on the x-axis when we draw this line. Okay, and same thing goes for this equation. We have our slope, which is -4, and then we have our y-intercept, and we have a variable represented by x, meaning any point on the x-axis from 0 into positive infinity and from 0 into negative infinity on the x-axis. We can plug any of those points into here, and we would find a value of y that takes us directly to a point on this line. Same thing with this third equation. M, or the slope, is -2. The y-intercept is -13. And so we know that, again, if we're starting at the origin and we decide to go from to any point on the x-axis into positive infinity, or from 0 to any point on the x-axis into negative infinity, we could plug any of those random points into x, and it would automatically connect us to a point on this line that's on the y-axis, okay, or that corresponds to the y-axis. You want to follow these steps to find the equation of a line in the slope-intercept form. The first thing you want to do is substitute the values that you're given for the slope. So m, we've already established that m is our slope, and the xy coordinates into the slope-intercept equation. And then you want to be careful to not mix up x and y. And then you want to use the inverse operations to isolate b. So like we did, I think it was here, right? To isolate y, we moved 2x over to the right, or we subtracted 2x from both sides. If you wanted to isolate b, which is 15 in this case, you would just simply move 2x back over to the left-hand side, or you would subtract 2x from both sides of the equation, and then that would return us to this original form here. So just keep in mind that anytime you see a coefficient with no variable written next to it, okay, in this particular instance, 15, know that that's your y-intercept, or the point at which your line crosses the y-axis. We've established a slope, okay, and the ordered pairs x, y, and then you want to use inverse operations to isolate b, either moving values over the equal sign, depending on where b is located in the equation, right? And then you want to rewrite the equation in slope-intercept form, leaving x and y as variables and substituting values for m and b. And again, this will make more sense as we look at more examples. So you can access both the slope-intercept form and the
Point slope form.
from the online GED formula sheet. Just click on the word formula on the computer toolbar, and the sheet will become available. So in this example, you're told to use the slope-intercept form to find the equation of a line that has a slope m equals 4 and passes through the point -1, -6. If we go back to our, well, actually it's written here for you, right, in the third step, but this is our standard form of the equation, right? Y equals m x plus b, okay? That's always plus b, and then whatever information is given to you in your question will determine the sign of b. So you just want to start by plugging in the information you've been given into your standard formula, okay? We know that y equals -6, and so that's why we have -6 on the left-hand side here. And we know that the rest of our formula has to reflect m, which we're told is +4, and that's being multiplied by x, which is -1, right? So when we multiply 4 by -1, we'll have -4, okay? And so now we have our slope. Well, we don't know what our y-intercept is, but we can find it out. We can find it out simply by isolating b, which is what this second step is telling us, right? So we isolate b by moving -4 over the equal sign. So -6 plus 4 will give us -2, or you can simply add 4 to both sides of the equation. So -4 plus 4 is 0, -6 plus 4 is -2. Let me repeat that. You can solve for B in one of two ways. Okay, you can move -4 over the equal sign, and you would have +4 on the left-hand side. -6 plus 4 is -2, or you can add 4 to both sides of the equation. -4 plus 4 is 0, -6 plus 4 is -2, and so now we know, or we've established that B is -2, and then you would just rewrite your equation in standard form. Y equals, we know our slope, M equals 4. We're going to plug in 4 here, X, and we know that our y-intercept is -2. And this just means that once we graph this line, it's going to be a positive line because our slope is positive, right? There's no negative sign here. If this was a -4x, our line would be sloping downwards. So this equation simply means that once we graph this line, and we chose any arbitrary number or any random number on the number line from 0 to +infinity and from 0 to -infinity, any number or any value that we chose for x would, if we plug that value into this equation, it will automatically give us the corresponding value for y, or the ordered pair. So yeah, this is our equation rewritten in standard form, and you'll notice that anytime you rewrite the equation in standard form, you always have to leave y as a variable, and you always have to leave x as a variable. Why? Because you're simply saying that when we graph this line, we can choose any x value from -infinity to +infinity, and whatever value we choose and plug it back into this equation will automatically get a value for y that lands us on this line.
In other words, for our standard form equation, y equals 4x minus 2, which is lying on a coordinate plane with both the y and x axes running into positive and negative infinity, respectively, we can pick any value for x and plug that value into our equation, and it will provide us with a corresponding y value. We can then take that ordered pair produced from a random value of x, which helped us find a value for y. Once we plug it into our equation, we can then take our newly found ordered pair, and the location of that ordered pair will be on the line representing our equation y equals 4x minus 2, and this will be true for any random value of x or y that we choose on the number line. So as long as we have a value for one variable, we can always find the other. For example, if we have a value for x, we can find y, and vice versa. And the location of any ordered pair produced from plugging in either x or y into our equation, the location of any ordered pair produced will always land us on the line representing our equation. So will always land us on this line y equals 4x minus 2. And this will be true for any straight line that takes on the standard form y equals mx plus b.
All right, so use the point slope form to find an equation. The second important form that is used to describe a line on the mathematical reasoning test is the point slope form. Y minus y1 equals m times x minus x1. In this form, x1 and y1 is an ordered pair that corresponds to a point on the line. As in the slope-intercept form, m stands for the slope. If you simplify an equation in point slope form by solving for y, you will get the slope-intercept form of the equation. So follow these steps to find the equation of a line in the point slope form. The first thing you want to do is call the point that you're given x1, y1 and then put x1 and y1 values into the slope form equation, and then put the slope value in the point slope equation for m. Okay, and I know it might sound like gibberish, but it will make more sense when we do some examples. So here we're being told to use the point slope form to find the equation of the line that passes through the point 4, 3 and has a slope of 2. So we're given our ordered pair. So we already have information on x and y. We know that x is 4 and y is 3, and the slope of the line is 2, right? So again, you want to write your ordered pair. You want to start by writing your ordered pair first, and then you want to revert to this point slope equation that we were given here, right? So y minus y1 equals m times x minus x1. So go back to your ordered pair and plug that information into your point slope formula. Y1 is 3, so we're going to plug in 3 here. X1 is 4, so we're going to plug in 4 here where we see X1. And then you're pretty much done unless you're asked to simplify. This is now your point slope equation. In other words, this equation right here represents this line, meaning that, again, if we consider all the points that lie on our x-axis from negative infinity to positive infinity, if we chose any random point, we can go back to our formula that we established in step 3, and we can plug in x. Let's say x is 1. If we plug in here, 2 times 1 is 2, 2 times -4 is -8, right? And we know that once we found -6 on this side, so this entire right-hand side is now -6, we can find the value of y by simply moving 3 over the equal sign. So when we move 3 over the equal sign, -6 plus 3 is -3, and we now have our value for y. So that simply means that anytime x is 1, y will be -3. And you can do that for any random point on the x-axis, again, from negative infinity to positive infinity, and you'll always find the corresponding value for y.
And remember, our line also extends into positive and negative infinity, whether you're considering the x or y axes. So we can check our values that we just found. When x is 1, y is indeed -3. So our point slope form provided us with a coordinate pair that takes us back to a point on our original line.
Notice that you can simplify the equation to find the slope-intercept form, and you can do that by just multiplying the terms in brackets. So 2 times x is 2x, 2 times -4 is -8. Now we're left with y minus 3 equals 2x minus 8. And then to isolate y, we would just add 3 to both sides. -3 plus 3 is 0. So y plus 0, you would just write down y on the left-hand side. And then -8 plus 3 is -5, and that's where this comes from. And so this now looks like our standard form for a line. And I guess I'll point out that 2 here is our slope, and -5 is our y-intercept, okay? So 2 here represents m, and -5 represents b, or our y-intercept. More practice questions on page 991 to 994. Slope and unit rate. The unit rate is a way of showing the relationship between two variables as the ratio of how many units of one quantity there are per one unit of the other quantity. Unit rates are used constantly in everyday life, as well as in business, science, and the trades. On a given day, you might go to the butcher for a cut of meat that costs $2.99 per pound. So that would be an example of a unit rate. And for every pound of meat that you buy, you have to pay $2.89. So if you decided that you wanted to buy 10 pounds of meat, you would multiply 10 by $2.89 to get the price that you would need to pay at the counter. If you were merging on a highway and let's say you're increasing your speed to 55 miles per hour, that would be an example of a unit rate. If you're comparing LED and fluorescent light bulbs at a hardware store, and you see that the fluorescents use an extra 1.8 kilojoules, so that's what this kJ represents, kilojoules of electricity per hour, that would be another example of a unit rate. So the slope of a line is equivalent to the rate when the slope is written as a whole number, e.g. 55 miles per hour, or as a decimal, e.g. 2.89 or $2.89 per pound. Okay, so if it helps, anytime you see the word per, you know that you're dealing with a rate. And rates and slopes are equivalent in the sense that on a line that has a slope, you find the slope by finding your rise over your run. When you're dealing with unit rates, it's always going to be a particular quantity per another quantity. And so they find equivalency in the sense that your slope is essentially a rate, but without a unit of measure like miles or hours or miles per hour. A unit rate just simply adds a unit of measure to your slope. So that's the main thing to keep in mind, is that when you're dealing with just the slope of a line, we're not talking in terms of unit measurements, right? We're just talking simply in terms of coefficients, rise over run, right? But when you're dealing with unit rates, you're talking about, or you're comparing measured quantities with each other. 55 miles per hour, $2.89 per pound, things like that. A rate is usually written as a number of units of quantity y per 1 unit of quantity x. And so here we see again the same fundamental principle. We have our rise, or y, per or over our run, with our quantity x. This value is called the unit rate. It is possible to determine rate with just one value each for y and x variables, when you know that when the x value is 0, the y is also 0. E.g., if you buy 0 apples, you pay $0, okay? And so if we're looking at our number line, you would be standing at the origin 0, 0, right? And in this particular example, if you buy 0 apples, you pay $0. So your unit rate is 0, or you don't have a slope, okay? Which makes sense when we translate the same concept on our number line. If we're at the origin 0, 0, we don't have a slope, right? We're not moving, we're not rising in any direction, and we're not moving along the x-axis either. There's no run, okay? So each of these everyday ratios compares two quantities, and the second quantity given per this is what would be repeated, or what would be represented by the x-axis of a graph. The unit rate quantity of y per 1 unit of x is the same as the slope of a line, representing the relationship calculated in the previous lessons as rise over run, with one difference. The unit rate is typically expressed in whole numbers or decimals rather than left in fraction form. I found this on virtualnerd.com, and I put this in here to make the examples that follow a little bit easier to understand. So here we're being told to find the slope of a line that's passing through points 0, -2, and 3, 4, right? So we have our ordered pairs. We have two ordered pairs here, right? So we'll consider this, or we'll let this be our first ordered pair. So with our first ordered pair, x1 is 0 and y1 is -2. And with our second ordered pair, x2, or x sub 2, as this is formally known, is 3, and y sub 2 is 4, okay? So we can go to our number line, and if we plug in these 2 points, or I shouldn't say plug in, if we graph these 2 points on our number line and we connect them together, we'll have some sort of line that's representative of the relationship between these 2 points, okay? So starting with our first ordered pair, let's go to our origin, and the information that we're being provided is that we're not moving on the x-axis, X is 0, right? And then if we go back to the information, it's telling us that Y is -2. So we're going to reflect that on the number line, 0 right here, and then we'll move 2 spaces downwards. This is -2, okay? And so this point right here is representative of our ordered pair, 0, -2, okay? Then we go back to our information provided. We're told that our second point is at 3, 4. So we're going to go back to our origin and we're going to move 3 spaces over to the right, because remember, we're always starting with X. We're going to move 3 paces over to the right and we're going to move 4 paces upwards, okay? And so now we've identified our second ordered pair on our coordinate axes. And if we can connect both points together, we now have a line that extends into positive infinity upwards. And so any point that okay, let me not jump ahead. So now we know that based on the information that we've graphed to draw our line, we can find the slope of this line, okay? In other words, we can find how steep this line is, right? So when you're writing ordered pairs, you always want to start with X first, but when you're finding the slope, you always want to start with Y. So we go back to our ordered pairs. Lisa, you okay? You trying to say something?
Yeah, I'm okay. I was gonna say.
Oh, thank you. Thank you so much. That's so kind. Okay. All right. So always remember, you always want to write down X first when you're writing down your ordered pairs. Okay. And when you're working on your slope, you always want to write down Y first. So we're going to go back to our ordered pairs to find the slope. We're going to look for Y2. This is Y2 right here. Why? Because it's our second Y value. Okay, so you're going to write down your second Y value, which is 4. Okay, minus, and we have this minus sign here because that's what the formula tells us that we should be doing. We should be subtracting Y2 from Y1. It doesn't matter if Y1 is negative, we're still subtracting. If Y2 is negative and Y1 is positive, guess what? We're still going to subtract. If they're both negative, guess what? We still have to subtract, okay? So here, we're going to reflect that what the formula tells us. Then we're going to go back to our information, and we know that Y1 is -2. So we're going to write down -2 in our spot here where Y1 belongs, right? And so we already know that to find the change, and that's what this triangle represents. It's the Greek letter delta, and that just means a change. So the change in our Y values is represented by 4 minus -2. We know from our lesson on signs that when you see 2 negative signs together, 4 minus -2 means 4 plus 2, right? 4 plus 2 equals 6. Then we go, so now we're done with our Y, right? Now we need to find our change in X. And we're going to start with X2 first. So we know from the information provided that X2 is 3. So we're going to write down 3 here where X2 belongs. And then X1 is 0. So we're going to write down 0 here where X1 belongs. The formula is telling us that we need to be subtracting both values. So 3 minus 0 is 3. And now we have our slope, 6/3, which is 2. So if we wanted to write the equation of this line, we would write it as Y equals 2x plus B. Here is our intercept, or the point where this line cuts through the y-axis. So B would be -2. So the equation for this line would be Y equals 2x. We get 2 from here, 2 is our slope, minus 2, which is our intercept. All right, so in this example, the coordinate grid shows the cost of gas at a particular station. AV and Beatrix partially filled 2 jerry cans separately and later graphed the values from their receipts to determine the relationship between cost, which is Y, and gallons of gas purchased, which is X. So we're being asked to determine the cost of gas from this coordinate grid. So let's pretend that this is their first receipt, okay? They bought 3 gallons of gas for $7.50. And how do we know that? Just by looking at the graph, right? We know at this point right here, it corresponds to 3 on the x-axis, and the x-axis, we're being told, represents gallons of gasoline. So at this point right here on our line, they bought 3 gallons of gasoline. Let's say our line represents a journey that they're taking, okay? At this point in their journey, okay, as they're traveling, right here, they bought 3 gallons of gas for $7.50. And we found that by just moving along or by matching this particular point with the corresponding spot on the y-axis, which happens to be 7.5. And then let's pretend that this is their second receipt, right? So at this point on their journey on this line, they decided to buy 5 gallons of gas, and for that they paid $12.50, okay? And that's represented by this ordered pair 12.5. All right. So now again, we'll go back to our question, determine the cost of gas from the coordinate grid. So what you're going to do is start by counting to find the rise and run between the two given points. The line moves up 5 when it moves 2 to the right. So you would write your ratio as 5/2, which is 2.5. And that's simply saying that it costs them $2.50 per gallon of gas, right? Because we know from our lesson on fractions that when you see a number written without a denominator, we automatically assume that that denominator is 1. Okay, that's what they're showing you here. And I went in and calculated the slope, since I think they jumped a couple steps. It might be a little bit confusing. So you find the slope using our standard formula that we saw somewhere here. Let me have passed it. Oh, right here, we know that the slope of a line is y2 minus y1 over x2 minus x1. So let's go back to our problem. We see that we have 2 ordered pairs, right? And so we can arbitrarily or we can randomly select which one will be our y2. I randomly selected this point, okay? So I said this is going to be our second ordered pair. So to find y, or the change in y, we're going to subtract our second y value, or y2, which is 12.5, from our first y value, which is 7.5. So that's how I did here. 12.5 minus 7.5 is 5. Then we're going to go back to our graph. Since this is y2, then this has got to be x2, right? So our slope formula tells us that we need to subtract x2 from x1. So 5 minus 3 gives us 2. And we know that our formula is rise over run, or the change in y that we just saw when we have 2 points, m equals y2 minus y1 over x2 minus x1. We've already done that. We found y2 minus y1. We found x2 minus x1. And now we just simply need to divide them by each other, right? So 5 divided by 2 is 2.5. That's where they got this from. They skipped a couple of steps, but essentially it was just still doing the same thing that we've been doing earlier, right? Rise over run. So let's say you just had 7.5 over 3. You could divide 7.5 by 3, okay? This would be y over x, because we know from our standard formula that the slope m equals y over x. So if you only had one ordered pair, you would be dividing y over x. If you have 2 ordered pairs like you have here, you have to find the difference between the second point and the first point for your y value, represented here. Then you would find the difference between the second point for your x value and the first coordinate point for your x value. You would subtract those 2 points from each other, and that would give you the change in x. Okay, and then you would divide. And if you can think of this again as just being y over x, because y here represents our delta y, or our change in y, and 2 here represents our delta x, or our change in x. So you divide the two values that you found by each other, and you would get your slope, or your unit measure. So you would interpret this as the cost of gas at this particular station is $2.50 per gallon. And again, we know that it's just 1 gallon because we don't have a denominator for this particular value. And so we automatically assume that that number is 1, right? And so this can be read as $2.50 per gallon. Note, you may have noticed that in this example, you can get the same answer by just dividing 7.5 by 3, or by dividing 12.5 by 5. So I think I mentioned that earlier. Let's say you were just given 1 point, right? Instead of 2, you can just use the information for that 1 point to find the slope. So either by dividing 7.5 by 3, if this was the only point that we had, if this was the only point that we had, you would divide 12.5 by 5. And this works because there's an implied third point in the proportional relationship. When you buy 0 gallons of gas, the cost is $0, right? So this 0, this would be our y1, this is y2, and this 3 would be your x2, and 0 would be your x1. But we don't bother with it because if you only had one pair, rather, you automatically assume that the second order pair is 0, which makes sense, right? This is just telling you that we don't have a second set of points. So you just do what? Divide the only y value that you have by the only x value that you have, okay? And it would lead you to the same slope. To determine rate, just take the fraction that represents slope and divide the numerator, or the top number, by the denominator, or the bottom number. Either version of the slope formula, rise over run, or y2 minus y1 over x2 minus x1, may be used to determine rate. Or you can just think of this as one large y and one large x if you only had 1 point, right? Y over x would still give you the correct slope in terms of the information that we're given here. So you would use this formula if you have 2 points, so 2 ordered pairs, I should say. You would use this formula. Or if you just had 1 point, you would just think of it as your rise over run. That's your car moving upwards on a slope, as we saw earlier. Rise over run, and you would use this formula right here. A technology company follows a predictable pricing trend where the price of a new product decreases linearly over time. The company releases a new smartphone at a retail price of $680. The following graph shows cost of the phone for the next 5 years. It is on the market as cost is represented by Y versus time in years, which is represented by X. So here we look at our graph, we see that our x-axis represents the number of years that this product has been on the market. In this case, the line stops at 5, letting us know that this product was on the market for exactly 5 years. And then the y-axis represents the cost. And you can see that the cost is diminishing, or the cost is dropping. For every year that this phone remains on the market, the cost drops. And so we can use this graph then to determine, let's say you wanted to find out the value of the phone at year 3, the third year that the phone was on the market. Well, you would just move 3 paces to the right on your x-axis, and then you would move from this particular spot upwards until you connect with your graph. And then you would find the corresponding y value happens to be 515, or it's given to us here. So we know that at year 3, it costs $515 to get the phone. Same thing with, let's say we decided year 4, we wanted to find out the value of this phone. We would move from 4 on the x-axis upwards till we connect with our graph, and then we would find the corresponding point on the y-axis. So we know that year 4, the price of the phone was $460. So that's essentially how we can use this graph to answer the question. Determine the rate at which the discount in pricing occurs. So again, remember earlier we established that a rate is a unit measure, right? And we know from our lesson on fractions that when you see per, right? It means you have a numerator, you have a denominator, and we know that a rate is a unit measure, and we've established that unit measures compare a certain value in terms of another, right? So like you're at the butcher store, you're going to compare a certain value or the dollar amount that you feel like spending in terms of another measure, weight or the pounds and meat that you want to buy, for example. Okay, so here we're being told to determine the rate at which discount pricing occurs. Well, we know that this graph is giving us information about a phone that's been on the market for 5 years, and it's also giving us information about the cost of the phone based on what year we're looking at on the graph, right? So we know that we can use this information to find the unit measure or the slope. Okay, so that's why we're finding the slope here, because remember we determined that the slope m is the same thing or corresponds to a unit measure. Okay, so all we're going to do is choose 2 points on the line, okay, and then plug in those 2 points into our slope formula to find the rate. So in this example, they decided to let x1 and y1 be represented by 0 and 680. And then they decided to let x2 and y2 be represented by 5 and 405. If they chose any other arbitrary set of points, let's say 2 and 570 and 3 and 515, your slope would be the same. The slope of a line is always constant, all right? So it doesn't matter which two set of points you work with, your slope will always be the same. And that's essentially what they're trying to illustrate here, that you can just choose any 2 arbitrary points that you like. Once you've done that, then you would substitute the values into the slope formula and solve, remembering to reduce to a whole number or a decimal rather than leaving the slope as a fraction. So here we decided that y1 is 680, therefore y2 has to be 405, right? So the first number that we're going to plug in here is y2, which is 405. And then we're going to subtract 405 from 680, right? And that's what they've done here. That's what we see here in the numerator. Then we're going to go back to our ordered pairs that we chose. We decided that we decided that 5 is x2. So we're going to plug in 5 here, and we're going to subtract that from x1, which is going to be 0. You can see that that's what they've done here, subtracted 5 from 0. And then you just continue with your procedural operation, which in this case is a division, whose negative 275 divided by 5 is negative 55. This negative sign makes sense, right? Because we determined that the longer this phone stays on the market, the more the price drops. And it's going to keep dropping until at some point when this line hits the x-axis, there'll be no corresponding y value, but the corresponding y value will be 0, meaning that at some point in the future, this phone will be worth nothing, or it will correspond to 0 on the y-axis. So you would interpret this answer by just simply stating that the smartphone model drops in price by $55 every year that is on the market. And that's what this negative sign represents. So in this example, we're told that a Minnesota construction company orders limestone, sand, and topsoil from a Canadian company, which uses the metric system. The purchasing officer knows that there are 2.2 pounds for every 1 kilogram. In other words, let's say you bought a scale to measure your weight and what you were in Canada, the scale would be in kilograms. So to convert it to a quantity that you know or that you're comfortable with, if you know your weight in pounds, you can find the equivalent, or you can understand the kilogram equivalent, right? Because this is the universal standard that's been established, that 2.2 pounds is equal to 1 kilogram. So the purchasing officer knows that there are 2.2 pounds per 1 kilogram of material. He decides to make a graph for reference when making purchases. Typically, he'll buy 100 kilograms, 500 kilograms, or 1,000 kilograms of material at a time, what will the graph look like? So this is a guy, he's always buying stuff in kilograms, but he's used to pounds. So he wants to create himself a chart so that he doesn't have to waste time converting anymore. If he decides tomorrow that he's buying 1,002 kilograms, he can look on this chart and find the corresponding equivalent in pounds. So the first thing that we're going to do is just kind of establish the information that we already have, right? So that we know that the material weighs 2.2 pounds per kilogram. So we're going to use the metric kilogram measurements as X values and the corresponding imperial pound measurements as Y values. So for 100 kilograms, we know that the pound equivalent will be 220 pounds. And so I just rewrote it on this side so that it can be easier to see what they're doing here. We've already established that 2.2 pounds represents 1 kilogram. In other words, if we have 1 kilogram, the equivalent is going to be 2.2 pounds, and we found that by multiplying 2.2 by 1. So using the same logic, if we have 100 kilograms, to find the pound equivalent, we would just multiply 100 kilograms by 2.2. If we have 500 kilograms, again, apply the same logic, multiply 500 by 2.2, you get 1,100 pounds. You have 1,000 kilograms, multiply that by 2.2, you get 2,200 kilograms. Now we can try to plot a graph based on the information that we have, right? So note that the slope of the line connecting the two dots is 2.2, right? So let's just pick any arbitrary point here. Let's say we pick here 100 kilograms. We can go to our line at 100 kilograms, which would be around halfway between 0 and 200, right? So here's 100 kilograms because the plot here is showing that axis is in kilograms and the y-axis is in pounds. So use the metric kilograms measurements as X values. They've done that here for us. So if this is 100 kilograms, we connect to our line, and then we move to the corresponding spot on the y-axis, and we know that that's 220, right? 2.2 times 100. We're just moving the decimal point over 2 places to the right. Okay, so that would be 220. So that's our first ordered pair, 100, 220. Okay, and then let's say that we wanted 500 kilograms to represent our second ordered pair. So at this point on the x-axis, 500, if we connect to our line and we find the corresponding spot on the y-axis, that should give us the equivalent in pounds, which is 1,100. And then we can use that information based on what we know about the formula of a slope, how it should look to find the slope of this line. Essentially, it's telling us that if we were to either use this formula here, or we just took one arbitrary point and divided y by x, we would get a slope of 2.2, which is the information that we started with. If you divided 1,100 by 500, for example, you would get 2.2. If you divided 2,200 by 1,000, you would get 2.2. If you divided 220 by 100, you would get 2.2. All right. Or you can decide that this is y2, this is y1. You would need to subtract 1,100 from 220,
which would give you 880. So that would be our numerator. And then we would go ahead and find x2 minus x1. So 500 minus 100 would give you 400. 880 divided by 400 is 2.2.
So that's essentially it for today. I will see you on Tuesday,
Thursday.
on Thursday.
Thursday. All
Okay.
right. Enjoy
All
the
right.
rest of your week.
You too. All right.
All right.
Bye.
Bye-bye.